Hello, once again I welcome all of you to the videos on resistors or in series and in parallel. To explain these resistors in series and in parallel, let me want to start with an activity. It's a battery, 9 volt battery, resistor, 10 ohm resistor. I take another resistor. I take some wires to make connections. And I need an ammeter. Keep ammeter. Now I keep the resistor here. I connect the ammeter and the battery. Then I connect the battery and the resistance. See, the circuit is completed. Now you observe the circuit. There is 9.9 ampere is flowing in the circuit. The value of the battery is 9 volt. The value of the resistor is 10 ohms. The current in the circuit is 0.9 ampere. How we arrived this value? For that, let us take Ohm's law. What Ohm's law says? V is equal to I times R. What is V? What is value of 9 volt? What about I? I we are going to find out. What is R? R is 10 ohms. So I is equal to 9 volt over 10 ohms. We get 0.9 ampere. I is equal to 0.9 ampere. We use Ohm's law for the circuit to find out the current in the circuit. Now I do, this is activity number 1. This is the activity number 1. Now I do the second activity. For that, I am going to disconnect this connection. I disconnected this connection. And I put another 10 ohm resistor here. See, again the circuit is closed. What happens now? Now I connected two resistance in series. In the last video, I have told you about the resistors or in series. Okay, now we are seeing what happens when a resistor or connected in series with the batteries. See, this is 10 ohms, this is 10 ohms. When both are connected together, the current is reduced from 9.9 ampere to 0.45 ampere. What happened? The resistance of the circuit has increased. How we can find out the current? Again we can use Ohm's law. So the activity number 2. V is equal to IR. Same 9 volt battery. For it we are going to find out the resistance. Now the resistors are connected in parallel, so RP. What is RP here? RP is equal to R1 plus R2. When a resistor are connected in series, they should be added. If you want to learn about how, in what logic, in what sense we adding this resistor, that you have you may study in your higher education. So now I add RP is equal to 10 ohms plus 10 ohms. We get 20 ohms here. So put here 20 ohms here. 9 volt is equal to I times 20. So I is equal to, I write here, I is equal to 9 volt by 20 ohms. We get what? I is equal to 0.05 ampere. 0.05 ampere. 0.05 ampere. We can use the calculator to arrive this value. How much? 9 divided by 20. How much? 0.45. Okay, 0.45 ampere. The activity number 2. Activity number 2. The resistance, when we connect the resistors in serial, the value of the current gets decrease. But when we connect the resistor in series, the total resistance value increases. This is activity number 2. In this activity number 3, we'll connect the resistor, put all the resistor in parallel. Okay. Now I split this junction. Split this also. Then I bring it here. Keep the resistor like that. Then we want to disconnect this junction also. We take another wire. Wait. See what is going to happen now? See, the value of current increased from 4.5 to 1.8. When two resistors are in series, the current was only 0.45 ampere. Here we got no 0.45 ampere. When the two resistors are connected in parallel, the value of the current increases. This is activity number 3. Activity number 3. Again we use Ohm's law. V is equal to R. V is the same 9 volt battery. We want to find out the I. What about R? R are in parallel. Oh, sorry, this is S. This would be S. Resistor in serial. Sorry. So R, P is in parallel. What is the formula to find out RP? R, oh, this is also RS, serial. Yes. Check. RP, 1 by RP is equal to 1 by R1 plus 1 by R2. This is resistor 1, this is resistor 2. Okay, so 1 by R1, P is equal to, 1 by RP is equal to 1 by 10 plus 1 by 10. How much we get? 1 by RP is equal to 10 plus 10 divided by 100. Simple arithmetic. So 1 by RP is equal to 20 by 100. Now take the reciprocal. So RP is equal to 100 by RP by 1 is equal to 100 by 20. How much we get? 5. We get 5. So 9 volt is equal to I into the value of how much RP? RP is just 5 ohms. When the resistor are connected in parallel, in the resultant resistance we get only 5 ohms. 5 ohms. So, okay, I is equal to 9 by 5 equal to I. Okay, take the calculator. 9 divided by 9 over 5. How much? 1.8 ampere. This is a 1.8 ampere. I is equal to 1.8 ampere. 1.8 ampere. If we add more resistance, the value will decrease. Where more resistance is in parallel, the current will increase. Okay, shall we see? I take another 10 ohm resistor. I take 2 wires. See, this is activity number 3, no? The value of current increases. From 1.8 to 2.7 ampere. 2.7 ampere. Look. Again we are going to find V is equal to IR. 9 volt. I times RP. What you should do? How we can find out the RP value? So again 1 by RP is equal to 1 by 10 plus 1 by 10 plus 1 by 10. What is the value of the 1 by 10 plus 1 by 10? We got how much we got? 20 by 100. 20 by 100 plus 1 by 10. 1 by 10. 1 by 10. What shall we do? This is multiplied by 10. Here also 10. We get 30 by 100. 30 by 100. 1 by RP equal to 30 by 100. See, follow this one. 1 by RP is equal to 30 by 100. What about RP? RP is equal to reciprocal of this value. No? Take reciprocal of the left hand side. So when we take reciprocal of the left hand side, RP will go to the numerator, 1 will come to denominator, 100 will go to numerator, 30 will come to denominator. How much you will get? 10 by 3. 10 by 3. Okay, this is RP. Now you put this value here. 9 volt is equal to I into 10 by 3. Now you take 10 by 3 to left hand side. What will happen? 3 will go to upper side. So 9 times 3 divided by 10 is equal to I. So how much we get? 27 by 10. We get 2.7 ampere. 2.7 ampere. So I think you all would have arrived. You would have guessed, no? If we add more resistance in parallel, what will happen? The flow of current will increase. See what is happening here. Suppose this is a tank, water is flowing. What will happen? The 3 tubes, we use 3 tubes. Suppose here 2.7 liters are coming. What will happen? The water will be distributed through this pipe, through this pipe, through this pipe. Okay. This I want to the next video, let me explain this in brief. With this I finish this video. Like that, one more thing I want to emphasize. No? Suppose if you remove all these resistors. Now I connected 3 resistors in parallel in serial. You look at 3 resistors in serial. See, I take one resistor, I take another resistor. See, now I have connected three resistors in series, 10, 10, 10. The value of current has decreased, no? The current has decreased. Shall I delete all those things? But the value of the current has decreased. Is activity number? I don't know the activity number. Just watch what happens. Again, V is equal to IR. Same 9 volt battery. I. What is R? Yes. R is equal to 10 plus 10 plus plus 10. 30. So 9 volt is equal to 30 ohms. So I is equal to 9 divided by 30 is equal to, no, I. How much we get? We get 0.3, right? Shall we use calculator? 9 over 30. 9 over 30. 0.3 ampere. 0.3 ampere. So, when there are more resistance, the current will decrease. When more resistance is put in serial, the current will decrease. So, this can be removed. See, now you see, let me do one activity. I remove all these. Now I connect this one. Now let me increase the value of this one into 30 ohms. Into 30 ohms. See, the value is 30. Instead of connecting 3 resistors in series, we can put only 30 resistors in the place of 3 resistors in series. So, see, 10, 10, 10, 10, 10. This is equal to single resistor of value of 30. That's what I have done here. That is what I have done here. Another experiment, parallel connection, what we to do? This is 10 ohms, 10 ohms. 10 plus 10. This is equal to single resistor of 5. Single resistor of 5. When resistor are connected in parallel, the resultant resistance will decrease. When resistor are put in serial, the resultant resistance will increase. Okay. Let me want to explain this.